Alright, so I know we're getting deep into this. I'm not asking anybody to memorize this. I just want you to appreciate that whenever we talk about systems, we can dive deep, 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 deep. There's lots of things to know, but thankfully, this happens to be a robot system. So the folks that design the barcode or design the robots to read the code, they have to know all of this at least once to make sure it works, or they have to know it in order to fix it. But the rest of us, we say, oh look, there's a barcode, and oh by the way, you'll notice I took the barcode and I flipped it back up right side again. It's the same barcode, a 0360002914552. We've already just proven to ourselves that 2 is the most appropriate check character for this guy. So, gosh, here we go again. These barcodes, for the computer to read it, are made up of bars. Yeah, we knew that. Again, this is called the UPC-12 because there's 12 digits down here. I want to very quickly, you know it's never quickly with me, I want to take a look at the bars and see how in the world these bars, how the computer can read this pattern of bars and get these numbers, which is kind of pretty impressive. So, all barcodes, they contain light bars and dark bars. Okay, that's not a revelation I wanted to say, but it's not as if there's only dark bars here and the rest are gaps. There are dark bars and light bars, and you can say black or white. It doesn't necessarily have to be exactly black or exactly light, so we just use the term light and dark. So this big gap right here, it's not a space, that's actually a very thick white bar. And then of course it's pretty obvious this is a very thick black bar. And because this is run by computers, and computers are digital and like to use ones and zeros, it's pretty easy to say, or at least to use for our demonstration, light bars are made up of zeros. A zero has a lot of white inside of it. So this is a 0 bar, and dark bars are made of ones. They almost look like a dark bar. So light bars are zeros, dark bars are 1. That's how the computer is going to represent it. So the bars, we mentioned earlier on, there's a start code, a middle code, and an end code. So if I look over here on our barcode, there's a start code, which is this guy right here. There's a middle code, which are these two guys right there, and there's an end code, which is these two guys right here. Now I said these two. It turns out if we look at light bars and dark bars, you can see that a single dark bar, like this guy over here, is this wide. This is actually a dark bar, a 1, followed by a light bar, which is this one in the middle, followed by a dark bar. Now I know, at least from my old eyes, it looks like this gap in between is much wider than the individual bars, but quite honestly, they're the same space. They're the same thickness. It's just sort of an optical illusion. Your eye sees this white area here, and it makes it look sort of bleeds into the dark and makes it look wider than it is. So number-wise, when the computer reads this code or scans this code, what it sees is a 1 followed by a 0 followed by a 1. That's the start code, or the start bar. At the very tail end, there's another one of those guys, a dark, a 1 followed by a 0 followed by a 1. So again, the start code is a 101, a 101, and the end code is a 101, a 101. The middle code, I mentioned there was 2 bars, it's actually 5. It's a 0 and a 1 and a 0 and a 1 and a 0. So if you look inside here, the middle bar is actually this 0 followed by this 1 followed by this 0 followed by this 1 so these 1, 2, 3, 4, 5 are the middle bars. I know I'm belaboring the crap out of this, but that's what it is. So right away, there's the start bars, the end code, or the end, I said bar, the start code, the end code, and the middle code. Hooray! All right, what about all of the bars in between? Well, all the bars in between represent these values, including the number system character here, and including the check character. The 2 is actually inside the bars, and the 0 is actually the first character inside the bars. It just so happens that the designers of the barcode back in the early 70s said, let's put the start code, because it's a single digit, out front. Let's put the check character, because it's a single digit, out back. And let's put the 5-digit manufacturer's code lumped in the middle. and the 5-digit item number lumped in the middle, so it's easier to read. Fantastic. Wonderful. So we have 6 characters on the left-hand side and 6 characters on the right-hand side. Again, we're only going this deep because it's fun. Sure, why not? Every character is 7 bars wide. Now, wait a minute. How many bars are there here? Remember, you have to remember that you can't just count the dark bars. You have to count the white bars as well. And the problem is, when you have multiple white bars next to each other, it looks like a wide white bar. And when you have multiple dark bars together, it looks like a wide dark bar. We're not talking about this wide bar right here being 1 bar. This wide bar right there is actually 3 ones or 3 dark bars together at the same time. This guy over here is 3 white bars. How wide is a bar? A bar is as wide as any one of these individual bars in either the start code or the stop code or the end characters. Okay. Each character has 2 groups of zeros or light bars and 2 groups of 1 bars. Again, this is a lot of detail. I'm not testing anybody on any of this. It's just, I think it's kind of cool. We spend so much time going from like, hey, here's my pen. It's made out of atoms. Let's learn everything there is to know about protons and neutrons and electrons in order to understand this stupid pen. Well, it turns out this barcode has lots of parts as well, so why not? So let's go take a look at these 2 groups of zeros and 2 groups of 1s, okay? So here we go, okay? On the left side, all the characters over here. If you want to say, or you want the computer to read a 0, these 7 bars, there's 7 of them, let's count, 1, 2, 3, 4, 5, 6, 7. It is a pattern of 0, 0, 0, which looks like a thick light bar, followed by 2 1s, which looks like a medium thickness dark bar, followed by a light bar, followed by a dark bar. Okay, so let's impress ourselves. A 0 on this side is light, 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 black, black, light, black. Okay? So let's do that. The first code after the start character is 101, is this guy. 1, 2, 3 is a very thick, a 3-0 thick light bar, followed by a 2-1 thick dark bar, followed by 1, 0, followed by 1, 1. So this is the 0. 0, 0, 0, 1, 1, 0, 1. Fantastic. Again, I'm glad a human is not required to sit there and scan register items, because I wouldn't be a human for very long, okay? Let's look at the next one. The next one is a 3. It is a 0, or a light bar, followed by a very thick, a 4-character 1, 1, 1, 1, and then a 0 and a 1. So let's take a look at that, okay? So we already said that this was a 0, 0, 0, 1, 1, 0, 1. That was our 0. The next one is 0, 1, 1, 1, 1, 1, 1, 1, 1, 0, 1. That's the 3. There's the 3. 0, 1, 1, 1, 1, 0, 1. That's the 3. Oh my gosh. We're not going to do this to the entire bar, because I'm going to go ahead and smack myself in the face if I did. Suffice it to say, these patterns of zeros and 1s all have in common there is a light bar followed by a dark bar followed by a light bar followed by a dark bar. 2 lights and 2 darks for all 9. All of the lights and all of the darks have different patterns and different widths. They can be as small as 1 number or as wide as 4 numbers in a row. Let's go to the right characters on this side, okay? Oh, by the way, we have more. On this side, we have the same values, but you'll notice if you look real quick, a 0 on the left is replaced by a 0 on the right by just changing all the 1s into zeros. They're sort of the opposite. So a 0 on the left is 0, 0, 0, 1, 1, 0, 1. A 0 on the right is 1, 1, 1, 0, 0, 1, 0. I'm just reading numbers. I'm not memorizing this. There's no way I would remember this or memorize this. So it turns out that Why the difference? Why is one opposite the other? And of course the reason is, let's see if my camera can do this. I have two hands. I have a right hand and I have a left hand. And from your perspective, I have a left hand and I have a right hand. They're mirror images of each other, just like these characters are mirror images of each other. In addition to having ones and zeros be different because they're mirror images, and computer scientists love this, the number of ones is odd in each of these. Okay, so the number 0 has has 3 ones. That's an odd number. For a 1, it has 3 ones. That's an odd number. Let's go to 3. It has 1, 2, 3, 4, 5. It's an odd number. Check me. All of these patterns on this side have an odd number of ones. Over here, all of these guys have an even number of ones. Oh my gosh. In computer science, we call that parity. So a total of odd numbers is odd parity. A total of even numbers is even parity. This is how the computer can read these bars and say, oh look, all of these bars have an odd number of ones. It now knows that it's reading the left-hand side of the barcode. If it goes through and says, oh, I see an even number of ones, it knows it's reading the right side of the barcode. And that doesn't matter if you scan the barcode from left to right or right to left. You're still going to have an even number of barcodes, or even number of ones on this side and an odd number of ones on this side. This is how the computer can decide and notice or discover if the barcode is upside down or backwards. It's pretty smart on the case of the human programmers and engineers and scientists, designers, but now we have robots to go ahead and scan this, and we don't have to define this to a human checkout person who's going to go ahead and either read these with their eyes or, God forbid, be asked to read these codes, the actual bars themselves, without actually reading the human part. That's pretty nasty. So, this is our last picture here. How do we read all these barcodes without going crazy? In fact, I'm going crazy to that. So again, light bars and the dark bars, they're all there. Robots. That's how we're doing this. So we'll be talking about robots next. How in the world do robots actually read this? Because we're not doing this using humans. All right, I have a headache. I'll see you in a bit.